Eutrophication is the excessive plant and algal growth due to the increased availability of nutrients. Nutrients that increase photosynthesis are nitrogen and phosphorus. Because of these nutrients, algae eat the nutrients and reproduce rapidly, which then create an algal bloom, therefore taking most of the oxygen up in the lake or the river, and not letting sunlight penetrate the bottom of the lake or the river. Once the algae has lived its life cycle and the plants have died, then bacteria start to grow, and the bacteria eat the dead algae, thus causing new nutrients to be expelled out into the lake water or river water, which then creates a whole cycle again of the algae eating those nutrients. Whatever oxygen left that the algae left, the bacteria will finish eating up that oxygen, and then thus leaving no oxygen left for any other living organism, which then causes a hypoxic zone. What leads for lakes, rivers, or oceans to become eutrophic are fertilizers, often used in farming. Sometimes these fertilizers run off into nearby water, causing an increase in nutrients and then causing that algal bloom. Human activities have accelerated the rate and extent of eutrophication through runoff from animal feedlots, mines, unsewered industrial sites, and mostly agricultural or irrigation. This is an example of an algal bloom on a lake. You can tell that the algal bloom is all on the surface of the lake, and clearly sunlight isn't penetrating through to the bottom of the lake, meaning that the algae is absorbing all of that sunlight. When algal blooms are this intense, this is stating that now there isn't much oxygen left for organisms, meaning there's major die-offs of organisms because they aren't able to survive in that type of environment since there isn't any oxygen.
Water quality sustains ecological processes that support native fish populations, vegetation, wetlands, and bird life. Lakes are an important source of fresh water and are home to many species of wildlife. You can see in this lake there aren't any signs of algae growth. It's a very healthy lake which supports many organisms living in it. Shows no sign of having much nitrogen or phosphorus in its water. It has very good water quality, meaning that the chances of it being eutrophic is very low. It has lots of oxygen in its water, meaning that its organisms can live.
An example of a eutrophic lake nearby is Lake Apopka, found here in Orange County. It had changed from being a clear, healthy lake to a huge hypoxic dead zone. The reason being was the agricultural farms found in the north shore of Lake Apopka. These agricultural processes caused a lot of runoff of nutrients into the lake, spreading huge algal blooms, and thus becoming a huge dead lake filled with green algae. More than 85% of the phosphorus going into the lake was from the farming on the north shore. Lake Apopka was a designated Superfund cleanup site. The restoration approach emphasizes the reduction in phosphorus inputs to reduce algal blooms and clear the water. Currently, Lake Apopka is still rebounding from its severe eutrophication, but it is coming back to life with wildlife already going back. The water is clear of algae and plants are starting to grow back. If you go to Lake Apopka, you will see many different types of birds, different types of grasses growing already on the water. It has come such a long way than it was in the 80s, for example. If you get the chance, Lake Apopka is a great rebound story of how restoration is possible for eutrophic zones. And all eutrophication zones are very dangerous to biodiversity and the health of lakes, rivers, and oceans. It is possible to get rid of in time, over long periods of time, to get rid of that algae, but it's going to take a lot of time and effort and hard work. Once you have an algal bloom, it is very hard to get rid of. This has been a special report. Melissa Gonzalez.